Hello class, my name is Thor Larson, and this is my CIT 230 presentation, XML versus JSON. First, what exactly are XML and JSON? These are part of the alphabet soup that we have become accustomed to in the computer world. What they are formats used for data interchange. In fact, they are the two most common formats used for data interchange on the web. What I mean by data interchange is that applications use these formats to share data with each other. They are human readable. This is not binary data that is getting transferred between these programs. The data is in a format that we can actually read, which I'm going to demonstrate to you in just a little bit. Yes, they are used to do the same thing, but each one does it in a completely different way. That does not mean necessarily that one is superior to the other. Let's start off with just a really quick history lesson. The very first computers had serious problems that they needed to solve. Men sporting crew cuts, skinny neckties, and dark suits were more worried about making a 10 megabyte hard drive fit into something smaller than a washing machine than they were concerned about making computers talk with each other. There really weren't that many computers in the world, and it was not a need right when computers started to become popular. The very first computer network started operating in 1969, and that networking was not much more than just simple file sharing. Although it didn't take long before the need was seen for applications running on these computers to share data. One of the very first data interchange formats is something that we know now as comma separated values, or CSV for short. This is very simple. Data is written as plain text, and each data field is separated by a comma. Now, the problem becomes that in that the routine that reads this data is written into every application that's running, and every application has a different routine that reads the incoming data. If there is a small change necessary to the data, then that means that the whole application has to be rewritten in order to accommodate this small change. In other words, it is not very scalable. So, what could be done? Well, a group of scientists got together and devised something called extensible markup language. This was introduced in 1996, and it is based on the same language that gives us today HTML, hypertext markup language. And you'll notice in my little code snippet here that XML looks very much like HTML. We have a tag system where we have a declarative tag at the very beginning that says that we are using XML and what version of XML we are using. We have tags that have an opening tag and a closing tag. There is also attributes that are possible for the tag. Now, also you'll see here that this is human readable. Everything in here is a word that you can recognize. And there is also a hierarchical data structure. Notice that we have here the publish tag, but below that are two child tags, Microsoft Press and 2004. There is also metadata and schemas that are defined using XML for each application that has to accept XML input format. You don't normally see those, but what they allow for is, let's say that your input data has to make a small change. Well, instead of going and refactoring the entire program. You only need to change the schemas and the metadata in order for the program to accommodate the new input data. Another thing is, and I know I'm about to use a bad word here, so please forgive me. They are system agnostic. What that means is that they run on systems, many different kinds of systems, and they also run on applications written in many kind of different programming languages. XML doesn't care what is running on each system. It doesn't care what the responding system is or the calling system is. It's just designed to handle the data no matter what it is and where it comes from. Now, it was originally based on a markup language used for marking up documents. And that kind of introduced an issue in that some data structures are not very well represented in XML. So some people got together later and came up with a solution to this data structure problem. This solution it came about in 2002 when it was released, and it was called JavaScript Object Notation. Now, it has some advantages over XML. It is less verbose. As you can see here, we don't have tags. We have something that actually looks a lot like a data structure that you come up with when you're writing in JavaScript. Also, it is written as a subset of JavaScript so that JavaScript can very easily understand this data as it comes in. Now, it is also used by two data communication protocols named REST and SOAP. I'm not going to dwell much on REST and SOAP, but I am going to say that these are the two communication protocols that are very useful in transmitting data using HTTP as the transmission source. Someone else will be talking about that in their presentation, I'm sure. It's still to come. Now, JSON and XML are not entirely perfect. Each one has its own strengths and weaknesses. The weaknesses to XML is that it always needs to have some kind of parsing before it can actually be read and understood by the application that is trying to use it. This parsing is something that means it has to separate the tags from the data. And like I had said earlier, it is not good for representing data structures, especially representing arrays. And REST is becoming more common as a data transmission protocol. REST can use XML and JSON. SOAP is not so common anymore. SOAP only uses XML. So as SOAP diminishes in popularity, so does XML. And like we can see, XML has both opening tags and closing tags and can become a little bit verbose. Weaknesses to JSON are that JSON is somewhat less secure, but I don't think that's intrinsic to JSON because JSON can be read directly by JavaScript. I think what makes XML more secure is that XML needs to have different things in order to make it understandable by the program that's trying to read it. It needs to have SOAP, it needs to have a parser, and because it has so many different things around it, that makes it more secure in transmitting that data over the web. And also, sometimes you really still need to transmit data as a document, and XML is better for sending that than JSON is because JSON does not represent mixed content very well. By mixed content, I want you to think of a font and how you have a font style, you have a font size, and you have a font weight. All of those can be very easily represented in XML just as attributes, the same way as we would see it in HTML. Okay, so right now what I'm going to do is I'm going to show you a small demonstration of how XML can be used in the real world. What I'm running here is an application that will let me show you how to use the XML. Okay, so let me give you a small demonstration of what XML and JSON look like in the real world. I'm going to use an application called Postman, which will make a call to a server somewhere in the world and get back useful data from it. What I'm going to do is I'm going to use, well, since we've been so concentrating on weather, I'm going to talk with a server that delivers weather information. Weather, openweathermap.org. And now first I'm going to show you what it looks like in what the return data looks like in XML. And nothing up my sleeve. What we have here is XML data, and this is what it looks like in JSON. It's just like magic, isn't it? Now, actually, what I had done earlier today is I went and did the same thing so I can show you the differences in the data um, in a larger format here. But anyway, this is the return data in XML format. As you can see, again, this looks very much like HTML. Here you can see we have the mixed data where we have a coordinate and longitude and latitude are attributes of the coordinate tag. You have the same thing here going on with pressure, where you have the actual value of the pressure and the unit that it uses here in as attributes to the pressure tag. In JSON, yeah, it looks a little bit different, and they do have different ways of getting around that. It's not really, that important since weather really is just data. But let me show you some other trick that I learned a few years ago. Right here is a Word document. And have you ever wondered what a Word document looks like? I'm going to show you a little trick that I learned. I'm going to rename this into a zip file. Yes, I am sure I want to change it. Now I can open up this zip file using an unzip program. And voila. So what this shows us is that Microsoft uses XML in transmitting its data to and from your desktop to not only the application already running on your desktop, but this is also used in transmitting your data to Office 365, which is, as we all know, Microsoft running on the internet to be used by everyone in the whole wide world. So even though we do see XML kind of waning in popularity, it's not going anywhere yet. Well, I hope that I was able to make something out of this explanation for you. I hope you understood everything. If you have any questions, you can always ask me directly. Please give me feedback on my presentation, and I will talk to you folks online.